Have you ever been stuck in an airport because your flight was delayed? Have you ever wished that you could predict whether a delay was going to occur so that you could plan accordingly? Flight operations managers face this problem on a near real-time basis throughout the day. However, due to the volume and complexity of the data associated with airline arrivals and departures, they're forced to make decisions based on yesterday's information because it takes at least 8 to 10 hours to run a single predictive model against the data. This lag results in suboptimal decisions because the managers can't respond quickly to changing conditions throughout the day. And as a result, this leads to unhappy customers who suddenly find themselves stranded in an airport for hours. What if the analysts who support the operations managers had access to technology that would enable them to refit models throughout the day as new updated data became available? What if they could try out multiple techniques or experiment with more complex models in order to increase the accuracy of their predictions? Reducing the time that it takes to fit and deploy the results of complex analytical models would enable airports and airlines to reduce the risk associated with delayed flights, decrease the costs associated with shuffling aircraft and passengers to respond to delays, and increase customer satisfaction for travelers like you and me. Today I'm going to introduce you to game-changing technology from SAS that will let me take a modeling process that historically would have taken hours to run and run the whole process live for you over the next few minutes. SAS High-Performance Analytics includes analytical capabilities spanning data exploration, modeling, and scoring, delivered on a database appliance that allows you to solve complex problems in a highly scalable, distributed environment using in-memory analytics processing. It lets you develop and deploy analytical models using complete data, not just a subset or aggregate, to get accurate and timely results. SAS High-Performance Analytics includes capabilities spanning the full analytics lifecycle. Today's demo will focus on using the SAS Enterprise Miner client to drive the high-performance analytical processing. This is SAS Enterprise Miner, our flagship data mining product, and we've loaded the airline data that we were talking about into Enterprise Miner. This is the data set that has over 120 million observations. It's a very large data set. And I've created a process flow diagram that's going to allow us to analyze this data. I'm going to start the processing on this diagram, and then I'm going to give you a quick tour through the history of how we've analyzed this data in the past and how high-performance analytics can help us do that in a more efficient and a faster way. If I right-click and choose Run, then we'll load the data up. And again, this is a large quantity of data, so it takes just a minute. You'll see the nodes processing. There's a node that's designed to do some basic exploration. We'll impute missing values, and then you'll see the modeling nodes start to light up, and we'll begin to do the backwards regression, the stepwise regression, the neural network. Some of this processing will happen concurrently. And while that's taking place, I'm going to move over to another diagram and give you a little bit more information. This diagram was designed to run against a traditional SAS server. This is the way historically these data would have been analyzed, and this is just a simple logistic regression. And I've already run this diagram, and if we take a look at the log file, we can see that the amount of time it used to actually run this model was about 7.5 hours. So an analyst would have to probably run this job overnight, or maybe run it first thing in the morning, check the results, and maybe run it one more time overnight. But they're limited and restricted to being able to only run maybe 1 or 2 models a day. So that's a big limitation in terms of trying to do things very quickly and to be able to innovate in terms of how you analyze the data. If I go back to Enterprise Miner, I have a second diagram. This diagram is also pointing to the airline data. We've added an exploration node, and now we're going to run that same logistic regression, that simple logistic regression, just like we did against the SAS server. Now we're going to run it against our high-performance computing appliance. And if we do that and take a look at the log file for this particular run, we see that it actually only took just a few seconds to run the same model. So now we've reduced our processing time from 7.5 hours down to 20 seconds. And that's a huge savings, and it makes a big difference in the life of an analyst. Now, instead of running a model once or maybe twice a day at best, I can run that model maybe 5 times or 10 times throughout the day. As new information becomes available, I can refresh my model, update that, and provide that information for making decisions that are based on the latest and greatest information available. So that's a huge savings for the analyst, and that's a big benefit of being able to use high-performance analytics. But now if we go back to our original diagram, we see that not only can we run individual modeling algorithms faster, we can actually set up a full process that supports the whole analytical life cycle of going from data to exploration to visualization to doing some transformation and imputation to make sure that the data is prepared and ready for analysis, that it's clean, and that we have what we need to be able to develop a good model. And now we can run not one model, but we can run, in this case, 4 models, or more than that. We can try different methods. We can try different configurations of the individual models, and we can do that very quickly. You can see that our last 2 nodes are still processing, and so we'll give that just a couple of more minutes to finish up the processing, and then we'll take a look at the results and compare the different models and see what we have learned from our airline data. So you can see that our process is completed. So just in the short amount of time that we've been talking, we've been able to run all of these models, and we've now collected the results in a single node that allows us to compare and see which one's performing the best for these particular data. If we take a look at the results, we can see that we have the lift charts, the ROC curves that allow us to compare the results. We have a number of different statistics that let us see which model is performing the best. In this particular case, it was one of the regression models that performed the best. We can now take the results from that model, and we can use that to make decisions about which flights are likely to be on time and which flights are likely to be delayed. The high-performance analytical procedures generate score code that can then be registered into SAS Model Manager for further validation, monitoring, and deployment. And once the model scores have been pushed into the operational environment, our Flight Operations Manager can then begin to use them to drive decisions on how to best manage air traffic flow based on the latest conditions, thus closing the loop on our analytic process. And we were able to accomplish that in just a matter of minutes. So high-performance analytics really is going to change the game for analysts and improve our ability to make better decisions faster.